All right, so this is a review for uniform circular motion. The number in the upper right-hand corner is 9948. First question says, a child is riding on a merry-go-round as the speed of the merry-go-round is doubled. So the speed is doubled. The magnitude of the centripetal force acting on the child is. So the formula for centripetal force is Fc equals mv squared over r. If you double v, basically your math becomes this, and if you work through that, it becomes m4v squared over r. If you look at how your new equation compares to your old equation is just mv squared over r. Here's mv squared over r. You have a 4 out in front. So basically your answer is quadrupled. Another way of looking at it is the centripetal force. If you say the mass and the radius aren't being changed, you can say they don't matter, and the centripetal force is, this is the symbol for proportional to v squared. So if I double v, Fc is going to go up by a factor of 4 times. Let's say I tripled v, it would go back up by a factor of 9 times the centripetal force would. You're going to encounter this over and over again in physics. I call them like what-if questions. What if I change this? How does it affect the answer? So really it's just about knowing sort of the mathematical relationship, which is another way of saying the equation. All right, next question. You have a certain mass car traveling at a constant speed. Turns at an intersection. It follows a horizontal circular path, which is what they're trying to show you here, with a radius of 25 meters to point P. When it gets at point P, there's an area of ice and it loses all frictional force. Now, when you're going around a turn, that's your circular motion. The force to the center, the centripetal force, is provided by the frictional force. If that's removed, we know that the velocity is tangent to begin with. If you remove the centripetal force, you continue moving in a straight line. So you're gonna fly off that turn tangent to it. The picture is not great, but to me it looks like at point P, B is the tangent. So that was my choice. Next question. The magnitude of centripetal force acting on the car as it travels around the circular path is approximately. So you're just going to do Fc equals mv squared over r. If you plug in all the appropriate information, 1,200 kilograms times 9 meters per second, we have to square that and divide it by 25 meters. I got an answer of about 3,900. I think it was 38.88 newtons, something like that, which is 3.9 times 10 to the 1/2 newtons. That's why we choose answer A. All right, next question. You see a student seated on a rotating circular platform, interesting, holding a 2-kilogram block with a spring scale. The block is 1.2 meters from the center of the platform, so that's R. The mass is that. The block is a constant speed, 8 meters per second. Frictional forces on the block are negligible. Which statement best describes the block's movement as the platform rotates? So it's always, as it goes in a circle, the velocity is always tangent. Tangent, spell it correctly. All right. The centripetal force is always pointing to the center, and the centripetal acceleration is also to the center. These are just things that you have to just know. This is sort of by definition for circular motion. All right. So if we look at it, the velocity is perpendicular. No. The velocity is tangent, yes. With an outward acceleration, it is not outward. The velocity is directed tangent. That's true. With an inward acceleration. That is our correct answer. Answer C. The reading on the spring scale. So we have no equation for this per se. What you have to realize is, why is this block moving in a circle? And it's the tension in the string. but that string is connected to the spring scale right here. So, if you were to analyze the spring scale, the force on the spring scale is the same as the tension in the string, which is the same as the centripetal force. We do have an equation for that. It's mv squared over r. So m is 2 kilograms. V squared, 8 meters per second. We have to square the whole thing. And r is 1.2. That gives you an answer of about 110 newtons, so it's answer A.